You are writing a report, maybe for work, maybe for school. You open ChatGPT, type a detailed prompt, and get back something that looks perfect. Well-structured, confident, full of specific facts and references. You submit it. Then, someone comes back and tells you the information was wrong. The study it cited doesn't exist. The statistic it quoted was made up, and the source it referenced never published. We have all probably been there at some point, and it is not your fault for trusting it. Every day, hundreds of thousands of people do the exact same thing. Because here is the thing, AI models are not designed to tell you when they don't know something. They are designed to always give you an answer. And that one design decision is quietly causing disasters at every level, from student reports to courtrooms to hospitals. In today's breakdown, you are going to find out exactly why AI models hallucinate and why that is not a bug waiting to be fixed, but a structural decision baked into how they are built. You are going to see why the newest, most advanced models are actually getting worse at this, not better, and why the people who built them are now admitting it may never fully go away. And by the end, you will understand something that most people using AI every day have no idea about. These systems were never designed to know what they do not know. They were designed to always give you an answer. And that single decision is already reshaping courtrooms, hospitals, and billion-dollar businesses in ways that nobody is talking about clearly enough. Let's get into it. A victim who trusted the machine. In 2023, a New York lawyer named Stephen Schwartz submitted a legal brief to a federal judge. It was 10 pages long. It cited 6 court cases, complete with real judge names, real docket numbers, real-sounding legal reasoning. Every single case was completely invented by ChatGPT. When Schwartz asked ChatGPT directly whether the cases were real, the model confidently said yes. The judge called one of the fabricated opinions gibberish, fined the lawyers $5,000, and the case became front-page news worldwide. This was not a technical glitch. This was the system doing exactly what it was built to do. And that is the uncomfortable truth at the heart of this video. What hallucination actually is. The word hallucination sounds dramatic, but in AI, it has a precise meaning. It is when a model generates content that is fluent, confident, and completely wrong. Not wrong in a clumsy way. Wrong in a convincing way. IBM defines it as a model that produces outputs that are nonsensical or altogether inaccurate, delivered with the same authority as valid facts. And it is more common than most people think. Studies show hallucination rates ranging from 3% to 27%, depending on the task. That means in the worst cases, more than 1 in 4 answers could contain something fabricated. But here is what makes this really interesting. The problem is not that the model is broken. The problem is that it is working exactly as designed. Inside the machine. To understand why, you need to know one thing about how these models work. At their core, AI language models do one thing. They predict the next word. That is it. They look at everything you wrote, everything they have ever been trained on, and they calculate what word is most likely to come next. Then the next. Then the next. One word at a time, until the answer is complete. There is no fact-checking step. There is no internal voice that says, "Wait, am I sure about this?" There is no truth meter running in the background. OpenAI's own researchers explained it this way in their September 2025 paper on hallucination. During training, the model sees enormous amounts of text, but none of it comes with labels that say, "This sentence is true," or "This sentence is false." The model only ever learns what language sounds right, not what is actually correct. They used a sharp analogy to explain it. Imagine you trained an algorithm on millions of photos of cats and dogs and asked it to guess each pet's birthday. No matter how advanced the algorithm, it would always fail, because birthdays are random. They cannot be predicted from patterns. Some facts work the same way. Low frequency, specific, obscure facts simply cannot be reliably learned from text patterns alone. So the model fills the gap with something plausible, something that sounds right, and it delivers it with full confidence. Think about it this way. These models have read virtually everything ever written by humans. But ask one to count how many times the letter R appears in the word strawberry, and it will often get it wrong. Not because it is stupid, because it was never trained to count characters. It was trained on patterns of language. It knows what words mean. It has no idea what they look like letter by letter. It cannot do something it was never shown how to do. This is the part that most people miss. These models do not produce new knowledge. They produce recombinations of what they were trained on. They are, at their core, extraordinarily sophisticated mirrors, reflecting back the patterns in their data. When the data has gaps, they do not stop. They fill those gaps with whatever sounds most plausible, and they do it with the same confident tone they use when they actually know the answer. This is why cognitive scientist Gary Marcus says these models literally don't know the difference between truth and falsehood. Everything that comes out of an AI, whether true or invented, comes from the exact same process. And this is the part that makes it truly dangerous. The model is not asking itself, is this correct? It is asking itself, does this sound correct? It is not checking facts. It is checking whether the answer looks polished, sounds confident, and feels like the kind of response a knowledgeable person would give. And it is extraordinarily good at that. So good that the wrong answer and the right answer come out looking identical. Why, I don't know, is nearly impossible. Now here is the question. If the model does not know something, why does it not just say so? Think about a student sitting a multiple choice exam. They hit a question they have no idea about. They have two options: leave it blank and guarantee zero, or take a wild guess and maybe get lucky. Over a full exam, the student who always guesses will almost always outscore the student who honestly admits they do not know. Guessing is the rational strategy. OpenAI's researchers describe it exactly this way in their hallucination paper. AI models are trained and ranked on accuracy benchmarks, scoreboards that reward correct answers. But they give zero credit for saying, I don't know. So the model learns, across millions of training examples, that guessing is always the better move. Silence is never rewarded. Confidence always is. Then, there is a second layer that makes it even harder to fix. After initial training, models go through a process called reinforcement learning from human feedback. Real people rate the model's responses, and the model learns to do more of what gets high ratings. And what do people rate highly? Answers that are helpful, complete, and confident. Not, I am not sure about this. Not, I do not have enough information to answer reliably. So layer by layer, the model gets shaped into something that always fills the gap, always sounds certain, always gives you something. Anthropic co-founder Daniela Amodei put it plainly, these models are really just designed to predict the next word, and so there will be some rate at which the model does that inaccurately. The result is a system that is architecturally incapable of comfortable silence. The damage is real. The lawyer case was not a one-off. Researcher Damien Charlaton's AI hallucination cases database has now logged over 1,500 court decisions worldwide, dealing with AI fabricated content. Bloomberg Law reported around 700 of those decisions came in 2025 alone, in just 1 year. But it is not only the courtroom. In February 2023, Google unveiled its AI chatbot Bard in a live public demonstration. It was a big moment. The world was watching. During the demo, Bard confidently stated that the James Webb Space Telescope had taken the first ever image of a planet outside our solar system. That is wrong. The European Southern Observatory did it back in 2004. According to NPR, Google Alphabet lost roughly $100 billion in market value the following day. One wrong answer. One demo. $100 billion gone. Then there is the medical world, where the stakes are not financial, but human. OpenAI's Whisper transcription tool was adopted by hospitals to automatically transcribe doctor-patient conversations. A study by researchers at Cornell and the University of Virginia found it was inventing text that was never spoken, fabricated medications, invented clinical statements, inserted into medical records. OpenAI itself warns that Whisper should not be used in high-risk domains. Yet medical centers adopted it anyway. And in Australia, consulting giant Deloitte delivered a 237-page report to the Australian government. It contained a fabricated quote from a federal court judgment and references to academic research papers that simply did not exist. Deloitte had to partially refund the government, around $290,000, returned, because an AI filled the gaps with things it made up. 3 different industries, 3 different kinds of damage, same root cause. Are the newer models better? You might be thinking, okay, but that was early AI. Surely the newer models have fixed this. This is the part of the video that should genuinely unsettle you. OpenAI's own system card for its o3 and o4 mini reasoning models, published in April 2025, showed that these newer models hallucinated more on factual benchmarks than older ones. o3 had a 33% hallucination rate. o4 mini hit 48%. The older o1 model sat at 16%. Read that again. The smarter the model became, the worse it got at knowing what it does not know. And the reason is almost darkly poetic. These newer models think harder. They reason through more steps, generate more statements, build longer chains of logic. And with every additional claim, there is another opportunity to fabricate something. More intelligence, more hallucination. The problem does not shrink as the model grows. In some ways, it scales with it. This is not a fringe finding. This came from OpenAI's own internal documentation. The company building the most widely used AI in the world is openly publishing data showing their best models are getting more confidently wrong, not less. A Stanford University study on legal AI tools confirmed the pattern holds, even when companies try to engineer their way around it. Purpose-built retrieval systems, designed specifically to reduce hallucination in legal research, still failed between 17 and 33% of the time. Some of these tools were marketed as hallucination-free. The Stanford researchers called that claim overstated. So the problem is not going away, and the fix is not just around the corner. What is being done? Researchers are not standing still. There are real approaches being developed. The most effective right now is called Retrieval Augmented Generation, or RAG. Instead of relying purely on what the model memorized during training, you connect it to a live, trusted knowledge base. The model retrieves real documents and grounds its answer in them. GPT-5's error rate on factual benchmarks reportedly drops from around 47% without web access to around 9.6% with it. Anthropic, the company behind Claude, explicitly advises building AI systems that allow the model to say, "I don't know," calling it a technique that can drastically reduce false information. And at Oxford, researchers published a method in the journal Nature in 2024 called semantic entropy. It works by asking the model the same question multiple times and measuring whether the answers mean the same thing. High variation flags a likely hallucination. It is an early warning system, detecting when the model is guessing rather than knowing. These are real steps forward. But none of them fully solve the problem. The Stanford study showed that even with retrieval grounding, Purpose-built legal AI tools still hallucinated between 17 and 33% of the time. The tools are getting better. The ceiling is not yet in sight. Can it ever be fully solved? So the question everyone is eventually asking is, will this ever fully go away? And here is where it gets genuinely fascinating. Because the people who built these systems do not agree. Sam Altman, OpenAI's CEO, said in 2023 that hallucination would reach a much better place within 2 years. He was optimistic. He believed it was an engineering problem waiting for an engineering solution. On the other side, Yann LeCun, Meta's chief AI scientist and one of the pioneers of modern deep learning, calls the current architecture a fundamental dead end. Not broken, fundamentally limited. He argues that no amount of scaling or fine-tuning will fix a system that learns from text patterns, but has no actual understanding of the world it is describing. Gary Marcus, a cognitive scientist who has been studying this longer than most, puts it even more directly. Hallucination is not a bug in the system. It is a property of the system. The very process that allows these models to generalize, to take patterns and apply them to new situations, is the same process that produces fabrication. You cannot have one without the other. And then there is the theoretical argument that may be the most unsettling of all. Academic researchers have now published work suggesting that any computable model that generalizes beyond its training data must hallucinate on some inputs. Not occasionally, not due to insufficient training, as a mathematical inevitability, like asking a map to show you territory it was never drawn from. OpenAI's own researchers land somewhere honest in the middle. A model can never be all-knowing, because some facts are simply absent from its data. But a model can, in principle, be trained to be honest about what it does not know. The goal is not a system that is always right. The goal is a system that knows when it might be wrong. Whether we ever get there is the open question. But the fact that the people building these systems are publicly debating it tells you something important. This is not a solved problem dressed up as a challenge. It is a genuine frontier. The takeaway. So here's where that leaves us. When you started this video, you probably thought of hallucination as a bug, an embarrassing glitch that would get patched in one of the next updates. Something the engineers were quietly working on in the background. But now you know it is something different. It is not a flaw in the system. It is the system, working exactly as designed, trained to always sound helpful, trained to always fill the gap, trained, in the deepest sense, to never admit uncertainty, because uncertainty scores 0. And that means we are not waiting for a fix. We are living with a fundamental property of the most powerful information tools ever built. Tools that are already inside our courtrooms, our hospitals, our governments, and our daily decisions. This does not mean AI is useless. It is extraordinary. But the people who use it without understanding this are not using a tool. They are trusting an oracle. And this oracle does not know what it does not know. The shift is simple, but it changes everything. Stop asking AI for answers. Start asking it for a starting point. Then verify what matters. Treat it like the most capable research assistant you have ever had. One that works at superhuman speed, but one that will occasionally and confidently send you in the completely wrong direction without a single warning. That is the breakdown. If this changed how you think about AI, hit the like button and subscribe. And drop a comment below. Have you ever been burned by an AI hallucination? Because I have a feeling this comment section is going to be very interesting. See you in the next one.